Hello everyone, and welcome to lesson 3.3, which is on evaluating expressions. Evaluating expressions is our first glimpse into the world of substitution. And what substitution actually is when we replace a variable that's in an expression for an actual number that allows us to solve and simplify problems. So, whenever we're doing this, you will be given an expression, and then you'll be given a couple of variables with what each variable is equal to. All we have to do is just trade out. We take out all the variables in the problem, and we put in the numbers that they represent. Once we do that, we trade it out just like a sub in basketball or soccer or any sport that we have. We trade those out. One comes out, one goes in. Now we have a math problem that we can solve and simplify. So let's go right into our examples here. We have 3x plus y is our expression, but then we're also told that x is equal to 4 and y is equal to 1. So if x is equal to 4, I'm going to underline that in blue, and y is equal to 1, which I'm going to underline in green, then we know all we have to do is put a 4 in for x, and we'll make sure I put that in blue, and then put a 1 in for y. So it just comes down to rewriting that problem. When I rewrite it, we're going to say 3. And it's always helpful that anytime we put a number in, we put it in parentheses just to know that we put the right number in. We can look, oh crap, we made a mistake. 1 doesn't go there. X is equal to 4. So we have 3 times 4 plus y, which is 1. So that gives us 3 times 4 plus 1. That is equal to 12 plus 1. Which is then equal to 13. So, to solve these problems, all we're doing is we're replacing the variables that are in the problem for the numbers that they represent. So that's your first example. Our second example takes us to something that's called function notation. And while you might not see a lot of this, and people think it's really confusing, in reality, it's the exact same kind of math. It's just written a different way. So we have f of x, that's how you read that first part, f of x, is equal to 2x plus 4. But then it says f negative 3, so that means f of negative 3. Basically, what this problem has told us is that x is equal to negative 3. Now, how do I know that? Well, I know that because in the original problem, there's an x inside that parentheses behind the f, and then for the clarification piece, they put 3 in. So, even if you see something like this, we don't have to make it more complicated. All we have to do is look at the original variable, which is in the parentheses, and then whatever number replaces it. That is still substitution. So, to write that problem, all I have to say is 2 times 3, negative 3, plus 4. So now I've done my substitution, and it's time to solve. 2 times negative 3 is negative 6. Now we can say negative 6 plus 4, and we know that negative 6 plus 4 is negative 2. So even though it's written differently, it's the exact same kind of math. Even though it's written differently, it's the exact same kind of math. It is substitution. All right, let's look at a couple more examples here. All right, so example 3. It says, is the solution below true given that x is equal to 3? So again, I'm going to highlight this. They've told us what we need to substitute, and then they've given us a full equation this time. Our job is to figure out if I put 3 into the problem, is it true? So let's go ahead and do that. We say 3, always in parentheses, squared, plus 4 times 3, plus 4. Now, at the end of the day, that whole thing should be equal to 24. Let's see if it is. Well, 3 squared is 9. Moving to the second term, 4 times 3 is 12. And then the last term is still 4. So now we just add. 9 plus 12 is 21 plus 4. And 21 plus 4 is 25. Does 25 equal to 24? No, it does not. So, is the solution below true? No, it's not. All right, and then our last one. It says, evaluate 2y plus 3y minus 2z, given that y is equal to 2 and z is equal to 4. Guys, this is the exact same kind of problem that we've been doing in the previous 3. It's just written in a different way, right? They give us our equation. I'm going to highlight the equation in green. Then they come back. They tell us what y is equal to, and they tell us what z is equal to. So, all we have to do, we can rewrite it in shorthand terms if we want to, right? We can say, hey, cool, 2y plus 3y minus 2z, and we know that y is equal to negative 2 and z is equal to 4. All right, cool. So that's exactly what we've had before. If you don't feel like you need that step, that's okay. But now we can substitute 2y is equal to negative 2. So I put that negative 2 in, plus 3. Y again is equal to negative 2. Plug that in. And then we say minus 2, and this time z is equal to 4. So now all we have to do is simplify each term. 2 times negative 2 is negative 4. 3 times negative 2 is negative 6. And 2 times 4 is 8. So we have negative 4 plus negative 6 minus 8. Negative 4 plus negative 6 is negative 10. And we're still going to do minus 8 on the end. Negative 10 minus 8 is negative 18. And we are done. So, as far as simplifying expressions goes, this is how we do it. It doesn't matter how they give it to you, and we've shown that they can give it to you in a lot of different ways. All you have to do is take out the variables and plug in the appropriate numbers, and then solve and simplify like we done in Chapter 2. All right, guys, hopefully this has been helpful. If you guys have any more questions for me, please let me know.